Hey, what's up everybody? So, in this example video, we'll just do questions 13, 14, 15, and example 2, A and B. Alright, so if we look at the first question here, we notice that it says compute each product and combine like terms, right? So they're just saying, take whatever this is and multiply it to each other. But here, if you freak out just because you see a square root x here, well, let's see. Let's say if I just say, what's x plus 2 times x plus 2? This is the same thing that we've just been doing, right? It's just FOIL. It's just this times this is x squared, this times this is 2x, this times this is 2x, and this times this is 4. And then we get what? We get x squared plus 4x plus 4. Okay, there's no way I'm going to review this because we have to know this by now. Now look, the same thing is happening here. You're just multiplying, instead of an x here, you just have a square root x. I mean, it's a little weird because we haven't really worked with radicals, but we're starting to work with them, okay? So get into that habit, right? Now here, what is square root of x times square root of x? That is equal to x, okay? And the idea behind that is this idea here, that if you have square root x times square root x, right? You have this times this. This is equal to x to the 1/2 times x to the 1/2. And that is equal to x to the 1, which is equal to x. Okay? That was the idea of what we talked about yesterday, that x to the 1 over n is equal to the nth root of x. So this idea holds over here. Oh yeah, wait, I have this for you. So let's just do it here. So here, square root of x times square root of x, that's x. Then what do? You do square root of x times minus 2, and that's minus 2 root x, you know? So if you have, you can't combine these two. It's literally just this minus 2 times that x, and that's what you get. Now here, you get 2 plus 2 square root x, and this is minus 4. Okay, now here, can we combine like terms? Well, here the x and the minus 4 we can't really combine, but can you combine these? And absolutely you can. Basically, just consider, like, even if you didn't have the radical here, for example, if you had minus 2x plus 2x, you just see that and that's 0. Well, the same thing happens if you have minus 2 radical x plus 2 radical x. You just think of it as a variable in a way. It just has a radical symbol. And if you feel weird about that, plug in a number. Let's say x is equal to, I don't know, 9. Well, let's evaluate that. What is minus 2 square root of x if x equals 9? Well, that's equal to minus 2 times square root of 9. So that's equal to minus 2 times 3. So that's equal to minus 6. So this is equal to minus 6. And positive 2 square root of x, that's equal to what? This is equal to, I'm sorry, that's minus 6. This will be 2 times square root of 9, which is equal to 2 times 3, which is 6. And here we have minus 6 plus 6, and that's 0. Okay, so if you just wanted to plug in a number just to check to see if it works, it still holds. So here, these two cancels, so we're just left with x minus 4, and that's it. Okay, now here, try and solve the same thing here, right? If you were to solve it, it would just be what? It would just be square root of x times square root of x, that is x. Square root of x times 4, that's positive 4 square root of x. If I do this, this is plus 4 square root of x, and this is plus 16. Okay, so here, what do we have? We have x plus, now how do you combine these two radicals? If I say what's 4 square root of x plus 4 square root of x, this is equal to just 8 square root of x, right? You're just adding it up. Yeah. Okay, so this is 8 square root of x, and then this is plus 16. And that's it. You can't do anything anymore. Okay. Now for this question here, we have what? We have x. Now here we have x minus. We have the square root of x minus 5 times the square root of x minus 5, right? And now we want to multiply these two. The thing you have to understand is that if I say what is square root of x times square root of x, that's equal to 1, right? I'm sorry, no. Whoa. That's equal to x, right? Because x to the 1/2 times x to the 1/2, which these two are equal to, is equal to x to the 1, which is equal to x. What if I have square root of x squared minus 7x plus 3 times square root of x squared minus 7x plus 3? Okay, this in disguise is still x squared minus 7x plus 3 to the 1/2, and so is this. This is x squared minus 7x plus 3 to the 1/2. And when you add these two, remember when you're multiplying this times this, it's still the same as if you have something to the 1/2 raised something to the raised to the 1/2. Okay, so this is just still, this is only just equal to x squared minus 7x plus 3. And this will be the same thing here. This is just x minus 5 to the 1/2 times x minus 5 to the 1/2, and that's just equal to x minus 5 to the 1, which is still just equal to x minus 5. And that is it. Okie dokie. Now, here in this question over here, it says rationalize the denominator in each expression. Okay, so what does that mean to rationalize the denominator? Okay, I wrote it down over here. I had some parts here. Let me zoom out a little bit. Here, questions for you to consider, and have it in your notes, right? In your Cornell notes setup. If you have your questions here and your notes, what does rationalize the denominator mean? This basically means remove the radical from the denominator. So here, that's what we have. If you look at this denominator, we have a square root of x minus 9. And in math, this is considered not simplified because there is a square root, there is a radical in the denominator. And look at this one here, there's a square root of x plus 3. You're not allowed, in math, it's not considered simple. Like this expression, this rational expression is not simplified. Actually, no, it's not even a rational expression. I'll talk about that after. But this is not simplified. Okay, so the game plan is, how can we simplify this? How can we get rid of this square root of x? How can we get rid of this radical? We want to change this to make it equal to something and get rid of this radical. What you're going to do is this little trick of multiplying by 1. And what you're going to do is multiply the top and the bottom by x minus 9. Okay? Because here, when you do this, you have the same thing divided by the same thing. This is secretly, this is just 1, right? This is equal to 1. So if you multiply this to this, you're not changing value, okay? You're just changing the way it looks. And notice that if you multiply this times this, the same way we multiplied this times this x minus square root of x minus 5 times square root of x minus 5 was just x minus 5. What did we accomplish? We got rid of that radical. And that's what we're going to do here. We're going to get rid of this radical. So what will happen to the denominator? That's just, the denominator is just equal to x minus 9, right? And this is x minus 9 times the square root of x minus 9. And can we simplify this anymore? Am I going crazy? Is there something? No, I don't think so. I think. All right, I'm just going to double check a little later. Actually, you know what? Let me pause real quick. Can I pause this video? Let's try this.